All right. Year 9. So this is direct proportion lesson 2. So in this video, we're going to continue on our study of direct proportion. Last time we've done some calculation for direct proportion using double line methods, right? So this time we are going to graph the direct proportion. So we could see how it looks like in a coordinate system. And also, we will introduce the ideas of independent and dependent variables. Okay, so let's just have a little bit revision what we have done last time. Okay, so here's the situation. You are paid $20 per hour. Okay, so we are going to find what would you pay. There are four different situations, right? One is if you work for 2 hours, 1 hour, 3 hours, and 0 hours. And of course, we know some answers directly because that's $20 per hour. It represents two quantities. One is the money, which is the core, which is the pay. The other one is the time. So you got two quantities, and these two quantities have different units. So this is a rate, all right? And which two time you would just get the pay immediately? I think for B you will know the answer right away, right? Because for B it's 1 hour, so that $20 per hour, so it would just be $20 for B. And for D, because you work for 0 hour, of course you are not going to have pay. That's 0. Okay, so we got two answers, but how about 2 hours? And we could use double line methods like what we've done last time. You write two columns. The first column is the pay in dollar sign. The other is time, which is in terms of hour. And you know 1 hour, $20. So you write the first pair of numbers, which is from the question. Now you are going to have 2 hours. Then you need to work on the ratio between the 1 hour and 2 hour. It means from 1 hour to 2 hours times 2. Okay, so how about the pay? So the double line method means on one side you times 2 from 1 to 2, then on the other side you are going to times the same factor. So that goes from $20 times 2, $40. So you are going to earn $40. That's it. B we've done. Okay, how about C? If you work for 3 hours, then it's from 1 to 3 in terms of time. Then you have to times 3, right? And to reflect that change, you have to do the same thing on the left hand side. You are going to times 3 for that $20. You got 60. Okay, right? And the last one, D, 0. Okay, so you got 4 pairs of data. So let's consider these 4 pairs of data. So if we want to put them into a coordinate system, there must be x coordinate and y coordinate, right? So let's say the x coordinate is what we call the time, which is in hour. Okay? And the y coordinate is what we call the pay, which is in dollars. Alright? Okay. So we know once 0 hour, 0 earnings were paid. So the corresponding coordinate should be 0, 0. That's the origin. So that's the first point right here. Okay. Okay. And the second point, you got number of hours 1, you got earning 20s. $20. Okay, so the corresponding coordinates will be 1 and 20. So this will be another point. How about 2? And the earnings will be $40, right? So it would be 240. 240. Okay, so let's find the point over here. You got 240, should be here. Last one, 3, that'll be 60. Okay. So you got another point. Okay, so let's connect them all together. Okay, so what kind of geometric figure will you see if you join all the points together? So you see a straight line. Okay, so that means if we have direct proportion for this, the pay and the time. Okay, so if you put them into two axes, x-axis and y-axis, and you got all the points according to that direct proportion, and you connect all the points, you will see a straight line. Okay, but will it happen every time when we have a direct proportion? The answer is yes. Okay, so here's a very important summary. Okay, so for two variables that are in direct proportion, we will have x, we will have y as two variables. Okay, so you will have some points. All right, you will have some points over here, and for all these points, okay, when you connect them together, you see a straight line. Okay, they pass through the origin. The origin is right here. Okay, we use O. Also, you will see the line erases. All right, or if you use what you've learned before, you could say they got positive slope. Positive slope. For that straight line. Okay. Okay, so that's the basic idea. So for the graph of a direct proportion, you will see a straight line passing through origin with positive slope or erases. Okay. Okay, so let's see which of the following represent direct proportion. Okay, let's see the first one. It's a straight line. It passes through origin with positive slope, so this is a direct proportion. For the second one, it's a straight line, positive slope, but does it pass through the origin? No, it does not pass through the origin, so it's not. Okay, because it doesn't pass through the origin. For this one, no, because it does not pass through the origin. Also, its slope is negative, it's not rising, it's falling, it's going down, right? And for this one, it's not a straight line, so this is not a direct proportion, so it's this one. Okay, so a direct proportion must satisfy three conditions: straight line, passing through origin, rises. Alright, okay, so let's have plotting direct proportion. I'm going to do one more example. Alright, but this time we're going to introduce we're going to introduce two variables first. One is called dependent variable, the other is called independent variable. Okay, so let's go back to the summary before we go into this example. Okay, so since there must be two variables, so one is called independent variable, the other is called dependent variable. For some of you, possibly you have learned that in science. Alright, okay, so what do we mean by independent variable? Independent variable is something we could change on purpose, so you could control it, you could change it. Okay, and dependent variable, so it's, as its name suggests, it depends on the other variable, which is independent variable, right? So normally we will use independent variable on x-axis, and you will use dependent variable on y-axis. Okay, so for the sake of clarity, let me just okay, so this is what we call independent variables, and this is what we call dependent variable. Okay. Oh, sorry. Okay, and also you might understand this by using what we call cause and effect. Okay, so normally when in science, normally we talk about the cause and effect. Okay, right? And for example, if we say since there's a cloud overhead, is going to rain. Okay, so the cause is a cloud and the effect is it rains, right? Okay, so that's the simple cause and effect. Okay, and what relates to independent variable and dependent variable is that for cause we refer to independent variable, for effects we refer to dependent variable. Okay, so that's the other way to see it. Okay, so when we say, for example, in our first demonstration is about earnings in terms of time, of course you could say because you've worked for 1 hour, okay, and you got pay of $20. Okay, so because you've worked for 1 hour, so that's the cause, because you say because, right? The cause is 1 hour work, the effect is you got paid for $20. Okay, so if you try to get the cause and effect, okay, exchange the cause and effect, sometimes it sounds strange. For example, if you say because you got $20, you have worked for 1 hour, so it sounds a bit strange. So not all the time cause and effect can be interchanged. Alright, okay, so that's what I want you to know. Okay, so actually we all understand that math is a very good tool for our understanding of interpretation of science and even our logic in our daily life. Okay, so cause and effect, so it's independent variable, dependent variable. That's another way to look at this. Alright, so and for the next demonstration is example 2. Okay, we will see number of hours, which is time, and also the pay, we use P. Okay, and so of course you would say number of hours should be the cause and the pay should be the effect, right? So normally in cause and effect, if there's a sequence in terms of time, cause should be ahead of effect, right? So you work first and you got paid, right? Okay. So and so we know that it's $10 per hour. So we use very simple numbers for the convenience of our demonstration. Okay, so we all understand if you work for 1 hour, you got $10, right? So if you work for 0 hours, what's the pay? Of course, should be 0. If you work for 1 hour, $10. Okay, so remember 1 hour, $10. How about 3 hours? Okay, so let's use a little bit of double line method, but this time we just don't draw it. We just try to imagine through the table. So from 1 hour to 3 hours, you times 3, right? Okay, so remember that's a direct proportion. If the time is increased by 3 times, then the pay should do the same kind of increase, which is 3 times. So it should be $30. Okay, then you will consider from 1 to 5 is times 5, right? And on here it should be times 5 as well. So page should be 50. So now how many pairs of data we've got? You got 4 pairs of data. All right. So copy and complete table. We've done that. Plot. Okay. So you see this word plot. That means you need to sketch the graph. This information on the graph. But before you do that, you need to have coordinates. Right, so you need to translate that table into coordinates. 0, 0 must be the point, and 1 hour, $10. So X is hour, Y is pay. So it should be I think something's wrong. It should be $10. Yeah, I should change that. Alright, so it's $10. 3 should be 30. Okay, 5 should be 50. Alright, so let's have 4 points. Okay, so the first point is over here. Where is 1 and 10? So 1 should be here, 10 should be here. Okay, so here's another point. And also we have 3, 30. Right, 3 for here, 30 is for here. Okay, and the last one, 5 and 50, right? So 5 and 50. All right, so over here. Right, so now you've got 4 points. Let's draw them together. Okay, so must be use that. Alright, okay, so that's a straight line. You pass through the origin. Also, it has a positive slope. Alright, so that seems correct. Okay, then we're going to have 2 terms. Okay, one term is interpolate, the other extrapolate. Alright. Okay, let me define what are the terms here. Okay, so let's say first term is interpolation. So that's the none, or that's one, interpolation. Okay, so just sorry. Try to okay. Interpolation means predict the data within the given range of data. Okay. Alright, so it's predict the value, possibly I should say predict the value. Alright. Okay, and okay, so that's interpolation. And how about extrapolation? So extrapolation is about predict the value outside, so one's within, the other is outside the given range of data. Okay, so these are two different ways to predict a value from the given data, right? So, and for example, so our data is from the number of hours is from 0 to 5, the pay is from 0 to 50, and if I ask you to find how many hours Tom would need to work to earn, okay, so you need to find number of hours work for when you earn $45. Since that $45 is less than 50, so that means it is within the given range of data, so it's what we call interpolate, right? So let's see how could we find it by using the graph, right? Then we might try to use another way, use double line method to see if the two results agree. Alright, so let's see if I earn $45. So where's our $45? Okay, so $45 should be here. So let me draw the line. Okay, so I'm using orange. Okay, so you touch this point and it goes down. Okay, let's remember how could we get it. First, you find the position for $45. Then you go across to the right hand side until you touch the line, and at this point you're going down in this way until you touch the x-axis, and you find out this value is 4.5. Okay, so let's answer the question first. Okay, for C, let's say, okay, so C Tom needs to work for 4.5 hours. Okay, right, so that's from our use of the graph. Let's track, okay, let's have a track if that's really correct by using double line method. So let's have a track. Okay, so for example, if I got number of hours and pay on the other side, so we've already learned that 1 hour $10. All right, so $10. Okay, now you are going to earn $45. Okay, so the problem is how many hours here. Okay, so using double line method, you will see from 10 to 45, what number are you going to multiply? If you still remember that, you could, if you need to find that number, you could use your target number, 45, divided by the number you start with, which is 10. Okay, 45 divided by 10 is 4.5. Okay, so that means you need to do the same on this side. So it should be 4.5 hours. Does it agree with the one we found by the graph? Yes, they are the same. Okay, so the track is complete. So it agrees with the double line method. Okay, so that's what we call interpolation. Okay, let's see the extrapolation. For extrapolation, let's see how much Tom will earn for 8.5 hours. Okay, so 8.5 hours. So this time, how much would Tom earn if we work for 8.5 hours? So the maximum number of hours in our data is 5 hours, but now you're asking to find the earning for 8.5 hours. So it's outside the given range. So that's why this case is what we call extrapolation. Alright, the last one is interpolation. Okay, so could we do that extrapolation using the graph? Of course we can, as long as you got the long enough graph. Okay, so let's find 8.5. Okay, we know that's 8, and in the middle it should be 9, so 8.5 should be here. Let's use another color. Okay, let's use green color. So 8.5. Okay, so this time we start from x-axis. Start from x-axis. So you go all the way up until you hit that graph, and you go all the way to the left hand side. And by doing so, you will see the value on that y-axis. Okay, so remember how to do it. Starting from x-axis, going up, hit the graph, go to the left until you reach that y-axis, and you are trying to check what value this is. Okay, it's halfway between 80 to 90, so it's 85, is that right? Okay, so our answer is Tom earns $85. Okay, if he works for 8.5 hours, right? So I'm not going to check that with double line method, but if you want to do so, you're welcome, right? Okay, so the answer will be correct. Alright, so okay, let's have a look for this one. So this one again, we will have two variables. So let's try to see what variable would be independent, what variable should be dependent. Tom drives at an average speed 90 km per hour. The table below represents the distance he traveled, D depending on the number of hours. Okay, so depending on the number of hours, so it's quite obvious. Dependent variable depends on independent variable, right? So hours should be independent variable, and distance should be dependent variable. Okay, and you know that's 90 km per hour. Okay, alright, so first you need to complete that table. Always start from 0, 0. Okay, suppose you travel for 2 hours. Okay, how long the distance? Okay, we don't have that data, but you know, if you use the double line method, it's t on one hand, d on the other. Right, so let's see. The question tells us if we have 1 hour, you travel, okay, 90 km. Alright, so if that's 2, what happens? Alright, and you're looking for this one. So if that's 2, that means times 2, right? And you have to times 2 on this side, so it becomes 180. So let's move 180 here. Okay, then you could use that to complete the rest of it. From 2 to 4 times 2, and it should be 360. And possibly would like to know this one 3, and you times 3 for this one. Okay, so that's it. So you got all the data ready for you now. And can you plot this information onto the graph paper right here? Okay, so first you need to have a coordinate. You need to translate your table into a coordinates right here. Alright, so these are coordinates you need to work for. Right, okay, so do you know how to do it? Okay, so I'm going to give you some time to plot the graph, and of course you need to be careful about the scale of the graph if you have such a graph paper with you. Alright, so I'm going to give you some time to do B. So I'm going to check with you whether your graph is correct. Okay, so you might pause the video now, okay, and try to plot the graph. Okay, so let's see. So here's the graph. You need to label that x-axis as time, y-axis as distance. Okay, so it's okay if you have a little bit different scale. For example, I use 2 units along the y-axis as 1 hour, so possibly use less or more. And also for each units on y-axis, my scale is 30, so I got 90 for 3 units. So possibly in your case it's different, but that's all good. Okay, so as long as you need to look at the data here. So interpolate, that won't be a problem. It's 4.5 hours. But how about 600 kilometers? So that's outside the current range, because the longest distance is 540. So you need to include at least that's 600, right? km on the y-axis. Okay, so basically you've done that. Then we're going to do interpolate and extrapolate. So for interpolate, how far Tom would travel for. Okay, so the first one's how far, so that's distance in 4.5 hours, and how long you would take to travel for 600 km. Alright, okay, so for C, how far in 4.5 hours, so we need to find where's the 4.5 hours. Okay, it's here, so let's move up here. Right, so okay, that's 4.5, and then you go all the way towards that y-axis. Okay, so sorry, it's a bit tricky drawing it on the computer. So it's not exactly 390, right? It's a bit more than that, so possibly you have to guess. So this would be cannot be exact for the graph, but that's okay because you are using the graph. So sometimes if they are not on exactly the position of the grid line, then that's okay. So you just say because that's 390 plus a little bit, plus each thing's 1/3 of 1 unit, so that's 10, right? So what 390 plus 10 is 400, right? So you just answer Tom would travel around, because it's not exactly 400 kilometer. Okay, so how about D? So this 600 kilometer, you need to find the time. Okay, So 600, okay, is 1 unit below 630. Okay, so just let me draw the line here, and then I'm going to move that towards the y-axis this time. Alright, okay, so let's see what value here it looks like is more than 6.5, but it's a bit more than 6.5, but not halfway between 6.5 and 7. So let's say 6.7. Right, let's say this is 6.7. Okay, so the answer is it takes around 6.7 hours. Right, of course, if you want to get a more accurate value, you could use double line method, but because the question is asking you to use graph, you have to use graph. Alright, so the practice 2, there are some questions here to conclude our for you to have further study on consolidation on what you've learned in this lesson. So it's about independent variable, dependent variable, how could you use the graphs, and also how could you plot a graph, and from the graph how could you predict the value both by using interpolation, extrapolation, or things like this. Okay, just please try to finish the homework and track the answer by yourself and send your homework to me. Alright, so if you have any questions regarding our content, you are welcome to ask question through OneNote or send an email to me. Right? Okay, so see you next time. Bye bye.